Now let's take a look at the elimination method. With elimination, when you add the variables x, you should have 0. Well, 3 and 2 don't make 0. Maybe adding the y values would make 0. -5 added to -6. Well, that doesn't add to 0 either. So this is where we might need to multiply one or both of these equations by some non-zero number so that we create coefficients that are opposites of each other. So if I just look at x, I've got 3 and 2. Try to come up with a common multiple, because I know that I'm not going to be able to multiply 3 by an integer and turn it into something smaller. So if I count by threes, 3, 6, 9, 12, so on. Then I'm going to count by twos, 2, 4, 6, 8, so on. Do you notice how both of these have a common multiple of 6? So that's a quick way to figure out what coefficient are we trying to turn these into. If I multiply this first equation by 2, then I know that I'll have 6x. So don't forget that every term in the equation would have to be multiplied by 2. For the second line, if I'm starting with 2x, then what would I have to multiply 2 by to make it the opposite of 6? So -3 would work. So let's go ahead and multiply through. For the first equation, every term is being multiplied by +2. So 2 times 3x would make 6x. 2 times -5y would make -10y. And 11 times 2 would make 22. Distributing -3 to the second equation, I would have -6x. -3 times -6y would be +18y, and 2 times -3 gives us -6. When I add these equations together now, you can see that 6 and -6 are going to be eliminated, and that's why this technique is called elimination method. We do, however, have some y remaining. -10 and +18 gives us +8y. And 22 minus 6 gives us +16. To finish this off, we're going to divide by 8, and therefore the y value is 2. So we know that we have one solution, and that solution is an ordered pair. The y value is +2. To figure out what the corresponding x value is, we're simply going to take a y value of 2 and substitute that into one of the original equations. I'll just go back to the first one. So 3 times x minus 5 times our new y value of 2 equals 11. That means 3x minus 10 equals 11. Adding 10 to both sides of the equation, we now have 3x equals 21, and division of 3 will give us an x value of +7. So +7 will complete our ordered pair solution. So this original system didn't have either x or y eliminating when we added them. So we had to multiply each equation by some factor such that we were able to create opposite coefficients, and therefore the terms with the x's was eliminated. Let's try another example. Here we have 2x minus 5y equals 12 and -4x plus 10y equals 20. So if I start by looking at the x column, 2 added to -4 doesn't make 0. -5 added to 10, that doesn't make 0 either. So I'm just going to start with x. Could I multiply 2 by some factor to make the opposite of -4? In other words, how can I change 2x into 4x? Well, all I have to do is multiply this equation by positive 2. So the new equation becomes 4x minus 10y equals 24. I'm changing nothing about that second equation. I'm just going to copy it. Negative 4x plus 10y equals 20. So when I add them together, sure enough, the terms with x do eliminate. Now how much y is remaining? Negative 10 plus 10. Well, that also eliminates. So I have 0 on the left side of this system, but when I add the right side together, I'm going to have 44. Does 0 equal 44? No. So when you end up with a statement that is false, that means there are no intersecting points or no points are shared by these two lines. So the only situation that could be is if your lines are parallel to each other. So we have no solution for this example because our lines are parallel. In our next example today, we have y equals 1/7 x plus 3 and x minus 7y equals negative 21. Well, these equations are not both in standard form. So the first one will have to be rearranged, and also we notice that there's a fraction involved. So we might want to eliminate the fraction, so we can multiply everything by 7. So we would have 7y equals, multiplying everything by 7 here, 7 times 1/7 x would just be x, and 7 times 3 would be plus 21. So we still want to do a little more work on this one and put it into the standard form. So I need to take x away from each side of the equation. Negative x plus 7y equals 21. Now my second equation over here is x minus 7y equals negative 21. So just lining that up, I notice that the terms with x are already going to eliminate. I don't need to multiply by anything. X is gone. 7 minus 7, the y variable is also eliminated. So I have 0 on the left side. 21 take away 21 is also 0. But notice how this time we ended up with a true statement. What that means is any point that is on the first line is also on the second line. They share all points in common, so they are the same line. So there's an infinite number of solutions. We have some application problems that can be solved by setting up linear systems. So in our first example here, we have Bono, and he bought 2 pears and 5 tacos for $9.89. Linus bought 4 pears and 8 tacos for $16.20. How much does a pear cost and how much does a taco cost? So you might use the variable p for pears and t for tacos. So we'll try to write a linear equation to describe what Bono is purchasing, and that would be 2 pears, so 2p, and 5 tacos, so 5t. And the price is $9.89, so that must equal 9.89. So notice how we have a linear equation in 2 variables to describe what Bono is purchasing. Next we have Linus. Linus bought 4 pears and 8 tacos for $16.20. So 4p plus 8t must equal 16.20. So here we have a nice linear system to solve. 2p and 4p are not going to add to make 0, but it would be fairly simple to multiply everything in the first equation by -2, and that way we would create -4p and positive 4p, and therefore elimination can be done. So let's go ahead and distribute this negative 2, and we'll have minus 4p and then minus 10t. And when we multiply negative 2 times $9.89, we're going to have negative 19.78. So now we can see with these two equations how 4p and negative 4p eliminate. Positive 8 and negative 10 will leave us negative 2t. And we'll combine positive 16.2 with negative 19.78, and that will give us negative 3.58. So don't worry about that turning out to be negative, because our next step, division of negative 2, will correct that. Price of one taco now is a negative divided by a negative, so see how that turns out to be a positive number. So the taco price turns out to be $1.79. Once you know the price of the taco, you can substitute 1.79 for t back in either one of the original equations. So I'll just go back to the first equation. 2p plus 5 times the price of the taco equals $9.89. So 2p plus $8.95 equals $9.89. Take away $8.95 from both sides. So when we have $9.89 minus $8.95, 9 minus 5 will give us 4 to borrow, and that leaves us. So when we divide by 2, we'll have the price of a pear. So 0.94 divided by 2 is going to give us 47 cents. And the question, how much does a pear cost? We know that is 47 cents. How much does a taco cost? That's $1.79. In our last example, we have James, who got a quote from a vacation tour of San Diego with Bon Voyage Travel Agency for 4 adults and 3 children for $2,900. James is going to buy 4 adult tickets and 3 children's tickets for $2,900. Our other person here, Connie, she got a quote for the same trip for 3 adult and 5 children tickets for a total of $3,000. So Connie's buying 3 adult tickets and 5 children's tickets for $3,000. So we want to figure out how we can make one of these variables eliminate. If I go back to the first equation, I could look at the 4 and 3 and notice that 4 and 3 have a common multiple of 12. So I'm going to multiply everything in the first equation by 3, and then I'll multiply everything in the second equation by minus 4. So our new equations become 12a plus 9c equals 2,900 times 3, 8,700. In the second equation, I'm going to distribute this negative 4, so I'll have minus 12a, and negative 4 times 5c would be minus 20c. And then multiplying 3,000 times negative 4 would be minus 12,000. So when we add these equations together, a is eliminated, and it looks like we've got negative 11c. And then we'll have to do a little subtraction off to the side here. 3,300. And since we had a negative 12,000 combined with positive 8,700, that would be a negative 3,300. Each side now is divided by negative 11. So C, or cost of children's tickets, must be $300. Now that we know the cost of the children's tickets, we can go back to either one of those original equations and make the substitution. So 4a plus 3 times 300 equals 2,900. 4a plus 900 equals 2,900. Subtracting 900 from each side, we're going to have 4a now equals 2,000. Divide each side by 4 to finish this off, and we'll have adult price is $500. So the adult fare is $500 and the children's fare is $300.